Okay, so this is Unit 1, Kinematics, Constant Velocity. This is going to be our very first unit over kinematics. Kinematics is basically the part of physics that studies how objects move without worrying about why they are moving. In later units, we'll talk about things like forces that actually cause things to move. But we're not going to worry about that right now. So we're just going to start off with the very, very basics. In this video, we're going to be talking about distance and displacement and what the similarities and differences between those things are. And then for the rest of this unit, we'll be talking about things like, what is speed? What is velocity? How do you solve problems with constant velocity using equations and graphs? How do you do calculations with average speed and average velocity? And how do you solve problems with relative motion? Now that sounds really complicated stuff, but this is going to be our first unit and probably one of our easiest units, just as something to get you more comfortable with physics. So before we get into distance and displacement, I do want to talk really quickly about units. Now, there's lots of different units for lots of different measurements. Okay, so just to give you an example for time, you can measure time in years, days, hours, seconds, and some combination of that. In science, we use a specific system of units called the SI system, or you might know it as the metric system. And so in this particular class, we're going to be using a specific set of units. Please make sure that you know about these units. This is important information that I would suggest you add into your notes because you can often look at units and use that as a context clue to get more information about the problem. Okay, so the unit that we're going to be using for distance and displacement is called the meter. Okay, for meter we write a lowercase m for meter. Now, if you don't know what a meter is, normally I would show you a meter stick, but a meter is a slightly longer unit of measurement than a yard. Okay, so a meter is 39.37 inches, just to give you an idea of length. So it's kind of like 3 feet, but it's a little more than 3 feet. The unit for time we're going to use is the second. For that, we write the lowercase s. The unit for speed and velocity is going to be meters per second. Now, notice that the way we write meters per second is m/s. Okay, so the slash represents per. Okay, so meters per second. And then the unit for acceleration, which we're not going to see until later on, but the unit for acceleration is meters per second squared, and we'll spend lots of time talking about why that is the unit for acceleration. But the reason, again, that units are important is because you can look at the unit and figure out what are you looking at. So, for example, if you're reading a physics problem and it says 10 meters per second squared, automatically you know that has to be acceleration because nothing else in physics has the unit of meters per second squared. And so just knowing the units for different things, you can use that as a context clue to help you solve problems. Okay, so now that you know about units and you've added that information to your notes, let's talk about distance and displacement. Okay, now distance and displacement are some of the things in physics that sound really similar, but they're actually two separate things. Okay, so let's be clear. There's three things I want to talk about: position, distance, and displacement. Okay, so position basically tells you where are you right now, right at this moment. Okay, and for position we write x. Okay, so if you imagine like walking along a number line, if you walk left and right on a number line, your position, your x value changes based off of where you are. Okay, now the distance that you've traveled is literally how far you have gone. Okay, for distance we're going to write d for distance. You'll see that later on. Displacement is not the same thing as distance. Okay, displacement has to do with how far away your endpoint is compared to your starting point. So in other words, for displacement, the only two things that matter is where are you now, what is your ending point, and what is your starting point, and nothing else in between matters. So for example, let's say you start walking right here where it says start. Okay, and let's say you walk around the green path that's shown. Okay, now depending on what path you take, you could end up here at the ending position. Okay, your distance is literally how far you walked along that path. Your displacement is just the difference between your ending position and your starting position. So in other words, what I'm saying is, if instead of taking this green path over here, let's say I went from the start to the end point like this, my distance would be much shorter because this black line segment is much shorter than the green path, but the displacement would be the same. Okay, and the reason the displacement would be the same is because my start position is the same, my ending position is the same, and those are the only two factors that affect displacement. Okay, so that's the difference between distance and displacement. Distance depends on how far you have literally traveled. Displacement depends on where your ending position is relative to your starting position. Distance, again, is measured in meters. Displacement is also measured in meters. We write delta x to represent displacement, and we write d to represent distance. Okay, but the units for both of them are the same. It's just that they mean two separate things. Now, we're going to do some examples so you can see more clearly what the difference between distance and displacement are. Please pause the video there in case you need to add any of that to your notes, which I would. Okay, so let's start off with a simple example. Okay, this is my walking example. So let's say I have a room, and you can see the two walls are right here and right here. And let's say the room is 10 meters across. I'm just making up a number. Okay, imagine this room as being like a number line. And over here on the left side is like x equals 0. And over here on the right side is like x equals 10 meters. Okay, so in other words, if you were standing on the left side of the room, your position would be 0 meters. If you were standing on the right side of the room, your position would be x equals 10 meters. Okay, so the room is 10 meters across. Okay, now, I'm going to make up an example. So, excuse my bad drawing. Okay, but let's say I'm going for a walk, and I start off on the left side of the room, and I start with a position of 0 meters. Okay, so I'm going to fill in my little chart here. My position, my x is 0 meters, and I have traveled a distance of 0 meters. And my displacement is also 0 meters, just because, well, I haven't done anything yet. Now let's say I decide to walk from the left side of the room, and I'm going to walk over here to the right side of the room. What is my position now? Well, my position now is 10 meters. What distance have I traveled? Well, the room is 10 meters across, so my distance traveled is 10 meters. And what is my displacement? What is my delta x? Well, the difference between my starting position over here and my ending position over here is also 10 meters. Okay, so in this situation, my distance and displacement are the same. Okay, but they're not always the same. Watch what happens now. I'm going to walk from the right side of the room. I'm going to go back all the way to where I started. Okay, so in other words, I've now walked back and forth across the room. What is my position now? Well, if I'm back at where I started, okay, imagine walking to the left on a number line. I'm now back at x equals 0 meters. I'm back at where I started. What distance have I traveled? Well, I walked 10 meters to the right side of the room, and then I walked another 10 meters back to the left side of the room. So my distance traveled is going to be 10 plus 10, which is 20 meters. That's how far I travel, okay, from beginning to end, 20 meters. What is my displacement? Okay, here's where you need to think. What was my starting position? Well, my starting position was the left side of the room at x equals 0 meters. What is my final position? My final position is also x equals 0 meters. That means my displacement is now 0 meters, okay, because I'm back to where I started. You might say, well, how can you have a displacement of 0 meters? That's because I'm back at where I started. If you start at one place and end up back in the same location, your displacement is 0 meters. Because remember, displacement is not how far you've traveled, it's only the difference between your starting position and your ending position. Okay, now, just to add one more row to my example, let's say, I've gone on this walk, and now I go all the way back over here to the right side of the room. Okay, my position is now at 10 meters. What distance have I traveled? Well, I went 10 meters to the right, then 10 meters to the left, plus another 10 meters back to the right. And so my distance traveled is now 30 meters. What is the difference between my starting position and my ending position? In other words, what is my displacement? Well, I started at 0, I ended at 10, so now my displacement is 10 meters. Alright, so hopefully with that example I just did, you're starting to grasp the difference between distance and displacement. Notice, by the way, that sometimes displacement and distance can be the same number, okay, but distance can never be less than displacement. Okay, notice that here in this first row they were 0 and 0, and then they were 10 and 10, and then the distance became more than the displacement, 20 meters and 0 meters, and then 30 meters and 10 meters. Okay, and so that's the difference between distance and displacement. Distance is how far you've traveled. Displacement is the difference between your starting position and your ending position. Okay, so pause there if you need to add this to your notes. Okay, moving on. Okay, so the difference between distance and displacement, this is just kind of a chart comparing the two. You can read it for yourself for the most part. They're both measured in meters. D is what we write for distance. Delta x is what we write for displacement. Okay, distance is how far you've traveled. Displacement is the difference between your start point and your end point. Distance cannot ever be negative. Okay, displacement can be negative. Distance can't be negative because the answer to the question, how far have you traveled, cannot be a negative answer. Okay, whereas your displacement can be negative if you travel, let's say, in the negative direction. In other words, displacement depends on direction and distance does not. Okay, so pause there if you need to look at that some more. Most of that is things we've talked about before. Okay, and I think this slide mostly has the same information. So let's just look at a few more examples. Okay, distance versus displacement. It says in the image shown, assume a person starts at point A and walks all around the rectangular path. So in other words, here's a person at position A, and they go from A to B to C to D, and then back to A. Okay. When they return to point A, their displacement is 0. Now, why is their displacement 0? Because their starting position was A, their ending position was also A, and so the difference between their starting point and their ending point was the same. Therefore, their displacement was 0. Okay, and so for this problem, I would write delta x, that's displacement, is 0 meters. Now, what is their distance traveled? Well, distance is how far they actually traveled, and so they went 3 meters, plus 5 meters, plus another 3 meters, plus another 5 meters, and so their total distance traveled was 16 meters. And so I would write D equals 16 meters. Okay, and so here their distance and displacement are definitely not the same. Okay, pause there if you need to look at some more. Okay, this is just another example of distance versus displacement. You can see in the picture, if a person starts right here, this is their starting position, and they want to get to here, either they can travel by river and only go 2.7 kilometers, km is kilometers, or they can travel by road and go 8.2 kilometers plus, what is that, 1.8 kilometers plus 4.5 kilometers. And so their displacement would be the same no matter what, because they end up in the same location either way. But if they take the road, they're going to travel a much greater distance, and if they take the river, they're going to travel a smaller distance. Okay, so this is a situation where there's two paths to take, both with the exact same displacement, but different distances traveled. Okay, so we're just going to do a couple examples. Take a look at example 2. Example 2, there is a race track right here, and the racetrack is 2.4 kilometers around. And the question says, if a driver goes 10 laps, starting at the start line and finishing at the finish line, what is the distance traveled and what is the displacement? Okay, so if they go around one time, they travel 2.4 kilometers. So if they go 10 laps, that means they go around 10 times. Their distance would be 10 times 2.4 kilometers. Okay, 10 times 2.4 kilometers is 24 kilometers. Remember, distance is just how far you've traveled. Their displacement, think about what their displacement would be. Okay, if they start at the start line, go around 10 times, and then finish at the finish line, their displacement would actually be 0 kilometers. And the reason is because even though they've gone around 10 times, their start point and their end point are the same. Therefore, they have a displacement of 0 kilometers. Okay, so that is example 2. Pause there if you need to look at that some more. Okay, and just to take a look at one more example, this is example 3. It says the girl in the diagram to the right travels from point A to point B, and then from point B to point C. Okay, so in other words, looking at the picture, she starts up here, and then she goes from A to B, and then from B to C. The distance traveled by the girl, okay, remember distance is literally how far the girl's traveled. She went 4 meters down, okay, so 4 meters, plus 3 meters from B to C. And so I would write D equals 4 plus 3, which is 7 meters. Okay, now her displacement, though, is not, so 4 plus 3 is a distance of 7 meters. Her displacement, though, is not 7 meters. Remember, what matters for displacement? The starting point, which is A, the ending point, which is C, and nothing else. Okay. In other words, for displacement, the path you take to get there doesn't matter. Okay. If you look at the difference between her start point at A and her end point at C, that is a displacement of 5 meters. Now, what if instead of going in a triangle, what if she had done this? What if she went up and over and did a crazy zigzag like this, and then ended up at point C? Now, her distance would be way, way bigger because she's traveled farther, but her displacement would still be 5 meters. Okay, remember, for displacement, all you care about is the start point and the end point, and nothing else in between matters. Okay, so that is our first video talking about distance and displacement. Please let me know if you have any questions, and as always, I will see you guys in the next video.